Why is voltage crucial for understanding Ohm's law fundamentals? Have you ever wondered why voltage is such an important concept in electrical engineering? Let's break it down and see how it connects to Ohm's law and circuit theory. Voltage is essentially the electrical potential difference between 2 points in a circuit. Think of it as the force that pushes electric charges through wires and components. Without voltage, there would be no current flowing in a circuit. Ohm's law is a fundamental principle that relates voltage, current, and resistance. The formula is simple. Voltage equals current multiplied by resistance. This means that if you know any two of these values, you can easily calculate the third. Understanding voltage helps you figure out how much current will flow through a circuit for a given resistance. This is key for designing and analyzing electrical circuits. When we talk about current, we are referring to the rate at which electric charge flows. Resistance is the property of a material that opposes this flow. So, when voltage increases while resistance stays the same, current also increases. On the flip side, if you keep the voltage constant and increase resistance, the current will decrease. This relationship is vital for engineers to predict how circuits will behave under different conditions. In practical terms, knowing the voltage in a circuit helps you understand how much energy is available to power devices like resistors, light-emitting diodes, and motors. For instance, when designing a circuit, if you know the voltage supply and the desired current, you can calculate the resistance needed to ensure everything operates correctly. Voltage is also essential when calculating electrical power. Power is the product of voltage and current. So, if you know both values, you can easily find out how much power a circuit is using. In more complex circuits, especially those involving alternating current and components like inductors and capacitors, voltage and current may not always move together. In these cases, impedance replaces simple resistance in Ohm's law. However, voltage remains a key factor in understanding how these circuits function. Overall, voltage is fundamental to Ohm's law because it drives current through resistance. This relationship forms the basis for analyzing, designing, and troubleshooting circuits in electrical engineering. Understanding voltage not only helps you grasp the basics of circuit theory but also equips you with the tools needed to work effectively in the field of electrical engineering.